Okay, continue from the last video. Assuming that we are given an IP address of 198.85.100.63/26. Again, /26 is the prefix, or sometimes call it the CIDR notation. And we want to find the total number of subnet for the given network. Find the network ID for each subnet. Find the total number of hosts available for each subnet, and listing all of the subnet, its network ID, first host ID, last host ID, and broadcast ID. Again, like I said, I'm going to show you the easy method. That is something that I figured out. Alright, number one, write down this CIDR notation into a binary number and convert it to a decimal value, and then it will become your subnet mask. So /26, meaning that we need to have 26 of number 1. Okay, right there. So each octet has 8-bit, so this is 8-bit of 1. Second octet has also 8-bit, make it total of 16. Third octet has another 8-bit, make it total of 24, and add 2 more, make total of 26. That's what the 26 coming from, 26 1-bit. And we simply fill the rest with 0. Alright, again, this side of the octet is called the host portion, and the other side right here is the network portion. This is the subnet basically, because the number is changing on this octet. The step number 2, convert the IP address to a binary. So we convert 198.85.100.63 to binary number, and that is right here. Now the third step, simply apply the AND logic function to the 2 binary number. It's right here. When we apply the AND logic function, we get 1, 1 is 1, 1, 1 is 1, 1, 0, 0, 1, 0 is 0, 1, 1 is 1, and 0, 1 is 0, 0, 1 is 0. So it looks pretty much like the multiplication table. Now I get the results right here. Simply convert this binary into a decimal number, and this decimal number is the network ID for this subnet right here. Okay, so 198.85.100.64 is the subnet, or is the network ID for the IP address of 198.85.100.63. Then the last step, or the next step, is to use the CIDR notation binary to determine the subnet and the number of hosts available in each subnet. To do that, we simply write down again 26 of 1 and fill in the rest with 0. And these 2 bit right here are the borrowed bit. We actually borrow this 2 bit from the host portion, so we call it the borrowed bit. And the formula for the subnet is 2 to the n. So what is n? N is 2. So 2 to the 2 is equal 4. So the total subnet for this setup IP is 4. Next thing, we need to find the hosts available in each subnet. Well, it's 2 to the h minus 2. That's the formula. Well, what is h? H is 6. Where do we get 6 from? Because there are 6 0. Okay? So 2 to the h is 2 to the 6 minus 2. So there are a total of 62 available IP address for us to assign to the end device on the subnet. work. Okay. Alright. How about the magic number? Well, magic number is the place value of the first bit on the borrowed bit. So the first borrowed bit is this one, and the place value is 64. So the magic number is 64. So to fill in our table, the subnet mask is 255.255.192. Subnet work, or the number of subnet, is 4, and the number of hosts available for each subnet is 62. Well, let's fill in the table, and again I want to delete this right here, so we'll come back to filling it, so you will see how that works. Alright. Okay. Alright. So the magic number is 64, meaning that from the first subnet to the second subnet, there are a total of 64 blocks. Okay, 64 blocks. Now our first subnet always begin with 0, so that's 198.85.100.0. We add 64 to that 0, make it 64. We add 64 to the 64, make it 128, and we add 64 to 128, make 192. Now if we add 64 to 192, make it 256. Again, that is exceed the highest available or used IP address. So the highest IP address used in network is 255. If we add that 64 to 192, get 256. So that is not a valid IP. Okay. All right. So now we want to find the broadcast ID for this subnet. Well, what is the broadcast ID or the broadcast IP address? That is simply one number lower than the next network ID. So that is 63. Now, how about the last host IP address? The last host IP address is one number lower than the broadcast ID. So that's 62. And what is the first host IP address? Well, that would be the number next to the network ID, which is 1. Okay. Now for this subnet right here, what is the broadcast ID or the broadcast IP address? Well, it is one number lower than the next network ID, and this network ID IP address is 128. So the broadcast ID for this subnet is 127, and the last host IP address for this subnet right here is 126, because it is one number lower than the broadcast ID. And of course, the first host or the first IP address for the host is 65. Now you should be able to fill in this quickly. This is 191, and this is 190, and this is 129. Okay. And again, the last broadcast ID or of the whole network is .255. Okay, always. Now question, what is the place value or the magic number? Well, we said it's 64. Right here we found it, so it's 64. Now next question, what is the network ID of the given IP 198.85.100.63? What is the network ID? Well, let's see, where is this .63 fall in under? Well, it is the broadcast ID of the first subnet. So it is belong to the 192.85.100.0 subnet or ID. Okay, so the network ID is 198.85.100.0 because right here this is a network ID of this subnet. Now next question, can this IP address be assigned to a host Or in other words, is it a valid IP address that we can assign to a host? The answer is no, because the IP address 198.85.100.63 already assigned to the broadcast ID. So it is the IP address of the broadcast ID. So we cannot use it to assign to any host. Okay? So the answer is no, because the IP address 198.85.100.63 is the broadcast ID for the subnet 198.85.100.0. Okay? Alright, let's look at another example. Given an IP address of 192.168.49.50/20. Again, /20 is the CIDR notation. And we want to find all the information about this subnet. So first step, write down the CIDR notation into a binary number and convert it to a decimal value. So 21, here you go, 8, 16, and then 20. Alright, they're total of 21, and we just fill the rest with 0. Okay, alright, that's what we work. Okay, now look at this right here. The first two octet is the network portion, and the last two octet are the host portion, because this is a class B subnet mask. Notice that the block that will change, that will be increment, is the second octet and the third octet and the fourth octet. So this is a class B. The next step is convert the IP address to a binary. So we already converted right here. I already converted right here for you. Then step number 3 is to apply the AND logic function to the two binary number. Okay, and we get this result right here, and the IP address or the network ID is 192.168.48.0. That is the decimal digit for this binary number. Alright, again, 192.168.48.0 is the network ID for this IP address right here, and the subnet mask 255.255.240.0. Next thing, we need to find the number of subnet for this network and the number of hosts, available hosts for each subnet. Well, again, we simply use the information here to determine our subnet. Now, there are a total of 4 borrowed bits. Okay, 4 borrowed bits. So our n is equal to 4. So 2 to the n is 2 to the 4. There are a total of 16 subnet. Now look at the host. There are a total of 12, because there are 8 zeros right here plus 4 zeros. So the h is equal to 12. So the formula for that is 2 to the h minus 2. 2 to the 12 minus 2 equals 4,996 minus 2, which is 4,094 available IP address that we can assign to the end device on the network. So there are a total of 4,094 IP address available that we can use to assign to a printer, server, switches, PC, okay, for the network. Now the magic number is 16. Why? Because it is the first bit of the borrow number, and the place value of this first bit is 16. 1, 2, 4, 8, and 16. Okay, so that's 16. Therefore, the first subnet is 192.168.00 all the way to 192.168.15.255. Okay, notice that the block changing is on the third octet. We add 16 to this 0 to get to the next subnet. We add 16 to these numbers right here to get to the next subnet, make it 32. We add 16 to that to be 48 to the fourth subnet, and you keep on adding that until you get total of 16 subnet. Okay, I'm not going to fill all of this information, but let's look at some more information in here. So the available host IP address ranging from 192.168.0.1 all the way through 192.168.15.254, which is a total of 4094 IP address. Now, for the first host IP address is 192.168.0.1, and the last host IP address 192.168.15.254. So the broadcast ID for this network ID is 192.168.15.255. Now, let's look at for the next IP address. Alright, the next IP address will be 2. For the next IP address will be 3. For the fifth IP address 4, 5, 6, and go all the way to 255. Now once you get to that, it increment this right here to 1, and the next IP address will be 0. The next IP address will be 1. Next IP address 2, 3, 4, 5, all the way to 255, and then increment this number right here to 2, and come back to 0. The next IP address is 1. Next IP address 2. Next IP address 3, and keep on going until it reaches the 15.254. That's how we get 4094 available IP address. Okay, I hope this is clear. Now let's look at the second subnet. It's ranging from 192.168.16.0. This is the network ID, and this is the broadcast ID, or the IP address for the broadcast ID. Okay, so available host IP address ranging from 192.168.16.1 all the way to .31.254. Why 31? Well, because 32 is belong to the next subnet. So one number lower than the next subnet is 32. Okay, right? I mean, it's 31. Now look at this right here. The broadcast ID is one number less than the next network ID, and the network ID in here is 48.0. So the one number lower than that is 47.255. Okay, alright, let's answer the question. What is the total or the place value or magic number? Well, that is 16. We find it right here. Now, what is the network ID of the given IP address right here? Well, the given IP address right here is .49.50. So .49.50 fall between this IP address right here. So the network ID is 192.168.48.0. There you go, it's right here. Okay, that is the alright network ID for the IP address. So we found that. As a matter of fact, we already found way up in here. Okay, alright, now can this IP address be assigned to a host? In other words, is this a valid IP address? And the answer is yes, because it's in this range right here. So it is. Yes, because 192.168.49.50 is in the range of the network 192.168.48.0. Okay? Alright. Thank you.